How has accidental discovery shaped modern medicine? Imagine a world where breakthroughs emerge not from methodical research, but from serendipitous events. From the accidental discovery of penicillin to the unintentional creation of medical X-rays, history is peppered with moments where chance played doctor. In the past, the pace of medical advancements was linear, a slow and steady progression dictated by these fortunate blunders. Life expectancy, a crude yet telling measure of medical progress, has seen a remarkable rise. 1,000 years ago, the average human lifespan was a mere 23 years. Fast forward to 200 years ago, and it had inched up to 37 years. Today, it hovers close to 80 years, a testament to centuries of accumulated medical knowledge and practice. But what happens when medicine meets the digital revolution? The turn of the 21st century marked a pivotal shift. With the decoding of the human genome, medicine transformed into an information technology. The Human Genome Project itself was a model of exponential growth, with genetic data doubling and the cost of sequencing plummeting by half each year. As technology evolved, so did the pace of discovery. Biomedicine surged forth, powered by an ever-expanding trove of data and increasingly sophisticated computational tools. It stands today as one of the most dramatically transformed areas of technology and industry. Dr. Hwa A. In his discourse on the intersection of health and wealth, highlights another crucial piece of the biological puzzle, the human microbiome. This vast array of microbes, outnumbering human cells 10 to 1, forms a complex ecosystem that plays a pivotal role in our health. It helps keep pathogens in check, regulates the immune system, aids in digestion, and even synthesizes vitamins. Yet, it remains sensitive to disruptions from diet, stress, and medication. Understanding the microbiome, paired with the power to simulate biological processes digitally, has ushered in a new era of biomedical innovation. We can now design interventions on computers and test them in simulations. Techniques like RNA interference and CRISPR gene editing allow us to update our biological software, offering treatments tailored not just to newborns, but to individuals at any stage of life. As we continue to unravel the mysteries of human biology, integrating our knowledge of the genome with that of the microbiome, we edge closer to a future where medicine is predictive, personalized, and profoundly effective. The journey from accidental discoveries to deliberate innovations in biomedicine not only highlights the evolution of medical science, but also underscores a future where every individual might have the tools to manage their health with unprecedented precision and foresight.